are central tendency values. These values represent the entire data set. With this value, we can compare one data set with another data set, or we can analyze further with these values. We can take decisions based on these values. Sometimes, if two data sets are having similar mean values or other central tendency values, in that case, statistically, the values will represent that both are having the same characteristics, but in reality, there are differences. So, in these cases, how we can take the decisions in a better manner? By dispersion technique, we can take a better decisions. So, dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which the numerical data is likely to vary about an average value. That means how far the observed values are away from its average value, or we can consider it as a mean value. Normally, in dispersion, two techniques are frequently used. Those are variance and standard deviation. Variance is represented with sigma square or a capital S square. It is average square deviation of values from mean. It is represented sigma square is equal to sum of x minus nu whole square by n. Variance means it's deduct the mean from each data in data set, then squaring each of them and adding each squared, and finally divide them by the total number of values in the data set. The square root of variance, this variance is known as standard deviation. We will see the properties of standard deviation. Standard deviation is only used to measure spread or dispersion around the mean of the data set. It is not it never in a negative values, standard deviation, and it is sensitive to outliers. Outliers in the sense extreme values in the data set. You may observe that majority of data set are in particular range, and suddenly you may observe that few data observations are with very extreme ended values. So these are called outliers. So if a single outlier in the data set will change the standard deviation value, and if you spread in the form of a curve, or if you construct a spreadsheet, so you will find a huge difference, a sudden variation in the data set. So that's why standard deviation is very sensitive to the outliers in the data set. For a data with approximately the same mean, the greater the spread, the greater the standard deviation. If the observed values and the mean all are similar, are same, then the standard deviation is 0. The standard deviation values will distribute at 3 levels. One is 1 standard deviation level, 2 standard deviation level, and 3 standard deviation. 1 standard deviation means mean plus or minus 1 standard deviation. So that means it covers maximum of 68% of the data. If it is two standard, if the data follows two standard distribution, so here 95% of the data is covered. If it is follows the three standard deviation, that means it covers about 99% of the data. For better understanding, if you consider 100 observations, so if the data follows one standard deviation, means out of 100, 6 observations are considered for the analysis. That means these are the fit for the analysis purpose. So what are the decision you are going to take? You are going to take with this 68% of the values or data. If your data follows two standard deviations, means it covers 95% of the observations or values. If your data follows three standard deviation, it covers about 99% of the observations. Out of 1000 observations, 997 observations are considered for the analysis. So the formula for variance is sigma square, or sometimes it will be represented as capital S, also S square. It is sum of x minus mu whole square by n. N is the total number of observations. If you square root of this variance value, we will get this standard deviation. Two different categories are there. One is for the population and another is for the sample. If you are calculating standard deviation or variance for a population, there you are going to take all the observations. Suppose we are calculating standard deviation for sample. So in that case, we have to subtract 1 from n. That means we have to write n minus 1. If it is population, we have to take only n. That means all the observations. If it is for sample, we have to take n minus 1 observations. So here standard deviation means we have to write n minus 1 for the sample. If you are not asked specifically for the sample, so then in that case we can consider in general for population. So let us see the procedure for calculating variance and standard deviation. First step is we have to calculate the mean of the data set. Then we have to subtract this mean from each observation. So this is, we have to calculate the mean, means x bar. Then we have to subtract this mean from each observation. So observation is, we used to consider it as a x, and we have to subtract the mean from the observation. So x minus x bar. So after that, we have to square this value x minus x. What the value we got after subtracting from x minus mean, okay, x bar. So we have to square. So after that, we have to add all the squared values what we are getting. Sum of we have to do. Then finally we have to divide these all the sum of squared values by the total number of observations. this is variance. Once we are getting the variance, if you square root it, square root of the variance, so we will get standard deviation.